This is this is so strange. But anyway, at least it's working now, right? So I will continue. Let's go on to the camera. So anyway, just wanted to show people what's in the box for this device because I think it's a really good buy. It's currently on AliExpress for something like £30, and for someone who just wants to get started with, FPV fixed wing, I think this is like the perfect start because you can't go cheaper than this. You literally can't go cheaper than this. You're in the sub 250 category, so you don't have to worry about regulations and stuff like that too much. And it's a nice start, but I just want to show people like what's in the box, just so they get an idea of what you get and what you don't get. So let me just get that. So there we go. That's the box. Mine came a little bit damaged, but from China, so not much that you can expect here. And actually, for £30, you get two of these. So one of them I've already built, so that's empty. And then the other one, I've got the parts for right here. So this is the canopy. You get the main wing. That's roughly how it looks like. It's all blank, so there's basically nothing on it, nothing there. They've made this such that it goes with one of their flight controllers, and there is like a mounting hole. These little mounting holes, I don't know if you can see them very well, but essentially there's like a little injection molded bit of plastic that you glue in there, and then you screw in your flight controller. But our flight controllers are a different size, so that doesn't work, and it's also very thin. So this is just a one layer flight controller, but I don't want to talk about that right now because essentially I don't have it and I don't know how good it is. People say that it's okay. I've read online that it has like an auto launch feature. It's got a barometer, so it's got altitude hold. It doesn't have support for GPS or anything fancier than that. So it's kind of limited, but this is what you do get. Apart from that, you get these tiny little LED, dual LED boards, I guess. I've tried to work them out with Inav, but I guess you just need to supply the correct voltage, which is 5 volts. And that's pretty much it. They plug in directly into the flight controller, the one that they supply, so you can use them. You don't have to. Also comes with 2 little carbon fiber strips. These are for the wings. They go on in this tiny little groove right there. So that's nice. You get a set of props. These are unfortunately spinning the opposite direction to what we're used to. So rather than having a prop that, as viewed from behind, is spinning clockwise, this one is actually spinning counterclockwise, which is a bit counterintuitive because what it means is that it will Can you unmute yourself, Ferris, and just explain what you meant?
Hi, yeah, it's sorry to interrupt, bro, but it's just because on YouTube there's a bit of a lag.
Yeah.
So I can hear you on Discord, but what you're saying, but I can see the camera on YouTube, so it's a bit out of sync. Is there
Okay.
any way you could put the like what you're displaying on YouTube also on Discord?
I could, but I have a feeling that it
It's
is
gonna
actually
muck up.
on Discord, but it is on Discord, but I think there's going to be a bit of a delay. So let me see if I can turn on camera. So you should be able to see my camera, but I don't know which camera it's going to display. So that'll be interesting. Yeah, I think it's going to struggle.
Okay, if it's gonna struggle, then my bad. Just sorry, continue. I'll just watch the YouTube.
Yeah, I think it's easier if you do that. But if you have questions at the end, you feel free to ask. So
No.
so essentially that's what you get. You get another box of goodies. So these are little servo covers that you get, which is, um, you might think that this is trivial, but not many airplanes come with these, and they're very good for small airplanes where you like to have a little bit of protection because you might be landing on grass and so on. And then, obviously, since there's two of these, two planes, you get two of them. I've only used one set so far. You also get a bunch of magnets, so you can mount the canopy nicely. You get some control horns and some push rods for your servos. And then there are a couple of other things which I'll show you in a moment, such as the ESC, which you'll need to buy separately if you get this kit, but it works out to be roughly around £50 here in the UK. So it's not that expensive to get all the little bits and pieces, and you might already have some of those things. And if we have a look at the other side, what I'm using for this build is a 1404. Let's see if the camera can display that. It's a 1404 3000 kV Ching motor. You can use a different one. They recommend actually a 5000 kV motor, but this one works fine with 2S as well, so not necessary to change. I've also got the servos. Now, the servos are slightly out of size for what we need them here, and I've already used mine, and I'll show you in just a second because I've got the build already done, but I just wanted to show people what's in the box, what you get. So you also get these two. So these are the vertical stabilizer fins. They don't come with a rudder, so this is just a fin. And then you've got bottom fins as well. So these mount onto the bottom side. Then there is another set of plastic bits. So you've got your fin protectors. These are these long thingies right there. You've got a camera lens protector that goes underneath, so right there at the front, and that's supposed to protect your camera and give it a nice like a bumper that you can use if you wanted to. Also adds a little bit of nose weight, so that helps. You've got the motor mount, which basically glues into the back, and then obviously we've got like other bits for the motor mount. I'm not gonna take them out because I'll show you in just a second what it looks like when you put all of this together. So just gonna chuck all of this into the box, and because I want to get as quickly as possible into the Inav part of the stream, I want to get over the build part as quickly as possible. So this is the final product, so to say. If we have a look on the underside, let's start with the underside first. We've got a nice little plastic grip. So this is where you will hold it if you wanted to launch it. This is nice. Not many come with this kind of underside. And for wings, it's especially important because there's two methods of launching a wing. The first method is to kind of grab it by the nose or grab it by the wing and just throw it sideways. But the problem is that by doing so, you're generating lift on the wing that you're not holding, and you're not generating wing where your hand is. So it's not great because the tendency will be that this will tip to one side or tip to the other side as you're throwing it. You can do it with a bigger wing, but with a small wing like this, it's not the best. Of course, you could grab it by the nose and throw it like that, throw it sideways like a boomerang, but you have to make sure that you're not adding rotation whilst you're throwing it. So I guess having this on the underside is definitely a benefit. Now, the servos are tiny little 2.7 gram servos, I believe it is. Let's have a look. 2.5 gram servos, sorry. So these are 2.5 gram servos from Emax. I think Emax makes very decent servos for the price. Some of them are metal gear. These ones are just plastic gear because they're very small and they don't have like that much resistance for these tiny little surfaces. I've also added some LEDs, and I'll show you how these are set up in Inav as well. And if we look towards the front, we've got a little camera with a camera lens, hood or lens, whatever they call it, protective lens. And if we have a look inside, you'll be surprised that there actually isn't a huge cable mess. because I have routed everything to be underneath the board. So if we have a look from one side, all the cables are essentially routed from underneath this 2-layer board. I'll show you in just a moment what this is. This is because this is just a Maytag flight controller. And to make sure that this can fit in the part where the canopy does become quite shallow, so towards the back, all I had to do was to lay the board on top, cut out the size roughly, and then slowly start cutting away from the surface from either side, as well as take my soldering iron and just melt the foam slightly inwards. But that just worked very nicely. Now, before you actually put in your motor, you do have to make sure that either you leave long enough cables so that you can stuff it in, or you keep this top side off, you route all your cables and all that, and then you put it on. So in terms of construction, this is really easy. I think anyone that has built a drone can easily build something like this. Wiring is trivial. I'll show you in a moment on the Maytag website. Everything is explained and self-explanatory. And the only other board that you might see is this one here in the middle. That is a Happy Model EP1 or EP2. Not sure which one, but it's the one with the SMD antenna. So no antenna sticking out, very small, but actually very capable. It's a very capable receiver. Supports Crossfire as the protocol, so you get all the goodies that you need to get with Inav or Betaflight. You could run Betaflight on this. I don't recommend it, but since this is an Inav stream. Yeah, the good thing about this flight controller is that, as you can see, there are no USB ports. And the reason why there are no USB ports is because it comes with this little extension daughter board that includes the beeper, an on-off switch for the beeper, a USB-C port, and on the other side we've got this tiny little JST SH 1mm pitch. I think this is a 6-pin cable. Yeah, so it's a 6-pin cable that goes into this daughter board, plugs right in there, and we'll be having a look at that in just a moment. So actually, I've set this up already in Inav, but I will be upgrading it to Inav 6.0 because right now this is actually running the release candidate, and I'll show you exactly what it is that you need to do. So first things first, let's plug it in. Oh, and by the way, this cable here is the one that you can see on the top is just for the GPS. I've decided to mount the GPS onto the hood. I think this is a good mounting position. It's away from the electronics and it's slightly higher up. So when you boot this up and you plug it in and you close the canopy and so on, it's a few centimeters off from the ground, which just allows you to have a faster locking time in my experience. So yeah, and you can see there the magnets are. So it's a very tight fit actually. Let me just remove this for a second. And then I just want you to hear the snapping because I have never heard a strong snap like this before. So there we go. That's a very, very solid, satisfying snap. And that's not coming off in the event of a crash, so you won't lose your electronics and nothing will... I mean, it has to probably be a very severe crash if if this comes apart. But anyway, let's go into Inav. So, first of all, let's launch Inav. Now, you can see that this is Inav 6.0 release candidate 1 on the top. That was in a very early stage of 6.0, but it had most of the things working. And if we plug this in, you'll see a bunch of lights coming on. Obviously, that's blinking, and it will be blinking faster in just a moment when it decides to turn on the Wi-Fi hotspot, which I hope my computer is not going to connect to. But anyway. So when we connect to that, very familiar interface to people who have seen Betaflight before. There are a couple of differences, of course, and the first thing that you'll need to do once you flash the firmware is actually to calibrate this. And this is the first difference between Betaflight and Inav. In Betaflight, we just have a simple button that we click in order to calibrate, and it does the calibration for us. In Inav, we do need to position the board in various orientations as shown in these images. There is a little on each and every Inav board, well actually on probably every flight controller board, there will be a little arrow. So I don't know if you can see that, but just next to the main chip, there's a small arrow right there, and that indicates the forward orientation. You can of course rotate this, but you know it's not necessary when you build something like this. When you're building it from scratch, I think only if you have really special requirements, you might need that. So once you go through all these steps, there's one thing worth noting, that you do step number 1, 2, 3, and so on, and then once you reach step 6, step number 1 will have to be repeated, and then once you repeat that, you will get values in your acceleration 0 and acceleration gain. And these values you can use in the future, and they stay the same, so you don't have to worry about ever losing them again, and you don't have to recalibrate the board every time that you upgrade Inav, and that's a really nice thing. In the mixer tab, we set up basically how we want the controls to be mixed. For most Inav flight controllers, for fixed wing, the S1 and S2 pads are reserved for motors. And it doesn't matter how many motors you're using, or whether it's 1, 2, or more. You could be using 3 motors, for example. 1 and 2 will always be motors. In my case, I'm only using 1 motor, so you can see that the S2 is actually not populated, but servo 1 and servo 2 are on S3 and S4. And so S3 and S4, if I just gently lift that up, you will be able to see that these are soldered on to the bottom side of this. And if we just have a look at the flight controller itself, which is the Maytech F405 WMN, this is the flight controller. If we have a look at the wiring for this, very easy to find good information because Maytech really does produce very good gear and has very good documentation. So it's absolutely a joy to be working with their electronics, because they have everything documented, and if ever anything does go wrong, you just send them an email, they'll tell you what part you need to replace, and yeah, Bob's your uncle. So as you can see, we've got the S1 and S2 pads right there. So these would be for motors. This can be configured as a dual motor configuration, and then our S3 and S4 are here at the bottom. So pretty easy. You just configure that. You can also use, with this particular board, you can use 6 volt servos. So some servos support 6 volts and are faster at 6 volts than compared to 5 volts. So if you, for example, solder these 2 connectors here, you can use a 6 volt servo as well. Some people might find this useful, especially for wings, because the faster our servos are, the more responsive they are, and essentially you get a very nice performance out of your wing. Obviously, these are very small servos; they only support 5 volts, so you don't actually have that. So let's continue in Inav. So this is essentially where you set up your mixes, and mixes are just saying, okay, so we've got servo number 1. It's color coded as well. So we've got servo number 1. So servo number 1, which is on the S3 pad, also labeled here as the S3 pad, which is taking in roll and pitch at a weight of 50% and 50%. So that's a standard mix. And many people get confused with how to set this up properly, but it's very easy. You just leave it as it is. All you need to do is you can load a mixer, load and apply, and then it will basically it will give you different options for what you want to choose. But then you also have a drop-down menu, so you can choose more specifically what type of mix you want to use. For example, fixed wing with differential thrust, airplane with VTail, and so on and so forth. Airplane with differential thrust. So this would be for something like the He-Wing Ranger T1, right? Where you have two motors, you want differential thrust, it will automatically apply that. And then the only thing that you might need to change is, because you're using differential thrust, you might want to add something like 0.3% yaw or minus 0.3%. Depends on the motors, depends how you've configured them. But essentially, if you watch the diagram, you should be good to go. On the outputs is where we actually change whether our servos need to be reversed or not. So we have a servo reverse section here, and the rest of the stuff you don't really need to change anything about, apart from enabling the outputs in the first place. Now, in my case, I've enabled the outputs, of course, and I have chosen DShot 600 for my ESC protocol. And this is because Inav supports just a wide variety of ESC protocols, and these are useful even if you're using fixed wing, simply because of the additional filtering that can be done and the behavior, such as setting up that ESC, right? So by default, you might want to set this up. I've chosen deliberately BL Heli S servos, BL Heli S ESCs. So these are the ones that I decided to go with. These are 7 amp ESCs. The recommended is a 6 amp 2S ESC. And the nice thing about them is that these are actually flashed with BL Heli S, and you can configure BL Heli S if you wanted to, such as configuring your minimum and maximum throttle, which by default is different than what Inav is using. So you might want to have a look at this and just verify what the settings are. We'll look into that in just a moment. Under the ports tab, you can see that this particular flight controller has quite a lot of UART ports compared to its size. It is comparable to the F411, but the problem with the F411 is that it only has 2 UARTs, so it's quite limited. It does have an S-Bus port, so if you are using S-Bus, you do have S-Bus plus 2 UARTs, but the problem is that 2 UARTs are not sufficient if you have, for example, a GPS. Maybe you want to use a DJI system, obviously not on something like this, but if you wanted to use it, you could, and in that case, you will need more than 2 UARTs because you'll need one for the GPS, one for your crossfire-capable receiver, and a third one for your DJI, as well as things like TBS Smart Audio. So you do need a third one, even if you're not using DJI, because you will want TBS Smart Audio to be on one of those ports. The Configurations tab allows you to modify and fine-tune certain things. So the sensors and buses, essentially, such as a barometer that's using the SPI interface and accelerometer, those are automatically loaded after you flash the firmware, because once you flash the firmware, you can choose to load the defaults, and these defaults are hard-coded in Inav, so you never have to really change them. Things like IC2 speed can be changed. The default is 400. I haven't changed it because mine is working fine as it is. You can change it if you wanted to, but this is usually for older boards, so I don't think that you actually need to touch any of this. The magnetometer alignment and the yaw degrees are something that you would only have to change if you change your orientation of your flight controller and your magnetometer. This particular GPS doesn't have a magnetometer, so actually I'm not using that, so it doesn't need to be looked at. Most of these things will be enabled by loading the defaults. The only thing that you might need to enable is the OSD output. So the analog OSD chip that's in here might need to be enabled, and the multicolor RGB LED strip support also needs to be enabled. It's not enabled by default. Then we've got the reason why I chose this board is because I wanted to make sure that I've got voltage and current readings on my OSD. So when we have a look at this section here, we can actually fine-tune these. You don't need to, and the defaults are actually pretty accurate. It's only when you either apply too much current and burn that shunt resistor, or if you do anything else where you damage your components, that you might need to fiddle with these settings because you've swapped a component and that component is not the same one. So in theory, you don't need to do anything here, but you might have to. Just saying. Now, battery settings are essentially just like with Betaflight, your battery settings. So you can adjust your maximum cell voltage, minimum cell voltage, and so on and so forth. And this automatically then calculates how many cells you have. Or for something like this, I know that I'm only going to use a 2-cell, so I might want to go ahead and use a 2-cell. But anyway, I'm going to leave this as 0 because it automatically calculates this anyway. We've also got our VTX interface, so we can choose what we want. This is only available when you have something like IRC, Immersion RC Tramp enabled on one of the UARTs, and or TBS Smart Audio. So whichever one you go with, this option will be here, and then you can choose your power level, you can choose your channel, you can choose your band, and so on. The nice thing about it is that if you're using Express LRS, you can use the Express LRS in your TX16S to be changing these values. So you don't actually need to change anything here. You can leave it as default, and that's it. Remember that after making any change to any page, it's always good to click Save and Reboot. Some options, changing certain options, does require save and reboot rather than just saving. So I recommend always save and reboot if you don't want to lose your settings. Now the failsafe tab is something that I haven't set up here. So we've got failsafe procedures that the fixed wing can use in order to safely return. Now we've got a few options. We can either drop, in which case everything will be turned off. It will go into horizon level mode, and after going into horizon level, it will just glide for as much as possible and it will crash somewhere. That's not a good idea, if you ask me. Landing is useful, but if you have flown away somewhere where you're quite a distance away, then you might not want to land right then and there after you've lost connection. So actually, this setting should be on return to home, and the return to home option will ensure that your aircraft returns to home after you've done that. So I'm just going to click Save and Reboot because I need to change that. It's something that I forgot in my initial setup. Under the PID tuning tab, you can do PID tuning. Just like for quadcopters, you can do PID tuning for airplanes as well. The defaults are mostly fine. You don't need to change them. You don't necessarily need to touch them. For your first flight, these should absolutely be fine. Your rates will also be fine, but of course, because we're flying fixed wing, we do have auto-tune. Now, just to explain a little bit around auto-tune, since Inav version 4, I think it was Inav version 4, auto-tune only changes the roll rate, pitch rate, and yaw rate, and the feed forward in our gains. It doesn't actually tune the PID controller, because the PID controller is something that you need to tune manually, and apparently the developers have found that it's the auto-tune is not that great, so they advise to leave these as default and then change them only after if you notice strange behavior. With a wing like this, you might notice strange behavior because this is mostly for wings that are, let's say, around 800 millimeters in wingspan, probably up to 2 meters in wingspan. If you create a large wing like that, these should be good. For something as small as this, we might need to change those values in the future, but because I haven't done any maidens with this yet, it's not something that I can do right now. In the advanced tuning tab, there are other bits and things that we need to have a look at, such as the GPS settings, the return to home. Well, actually, sorry, return to home settings. Whether it should land after return to home. So, for example, the default is to land in failsafe only. That's I would say that's a good default, because once your aircraft returns to you, if you have lost connection, you will reestablish connection, and it will say a prompt on the OSD that you can move the sticks, and it will exit the return to home loiter mode. You can also change the return to home altitude. You can enable things like return to home backtrack. This is something fairly new in Inav. It's not in this release candidate version, so we don't see it. But, backtrack mode you can turn on, but I don't think it works very well. So the actual release, which will be flashing on soon, is definitely, it has a trackback feature. So that means that basically it will try, if you have gone around certain objects, it will use the black box logs that it has created on the data flash to be able to track back its original path as recorded by the black box. So that's very interesting. Something that Betaflight doesn't have. Now, in the programming tab, there are interesting things that you can program, and I'll be posting my diff. This is essentially variable power levels as you change the distance. So as you're flying further and further away from yourself, this will start increasing the power levels. Of course, you might have to tweak this for the kind of video transmitter that you're using. But if you are using one that supports TBS Smart Audio or Immersion RC Tramp, then by changing these values here, you can adjust your power levels. So essentially what this is doing is within 100 meters, it's only using 25 milliwatts. Between 100 and 1000 meters, it'll be using the next power level, which in this case is 100 milliwatts. Between 1000 and 5000 meters, it'll be using 200 milliwatts. And everything above 5000 milliwatts, it'll be using, everything above 5000 meters distance to home will be using 300 milliwatts, which is the maximum that this video transmitter supports. Of course, other video transmitters will have other values, so you might need to tweak these values if you want to. Now, in previous versions of Inav, you used to be able to select an option that said override arming safety, and that was that. In our case, if you wanted to test your motors without having a GPS fix, the logic is this. So essentially just saying if... okay, my GoPro has decided to turn off. Interesting. Let's see if it comes back. Okay. Well, my GoPro has just died. So let me just turn that off. We don't actually need it. There we go. GoPro is off. So anyway, continuing. Override extra arming safety is still an option though, so you can turn this on, and if you wanted to just take off without a GPS fix, you can, but remember that if you do get a GPS fix during flight, you will essentially lock that as your new home location, and it might be an incorrect home location, in which case it will try and fly into a direction in failsafe where, you know, it's unpredictable, let's say. The receiver tab, much like the one in Betaflight, is just setting up your receiver. It supports a variety of serial protocols as well as MSP protocols. There used to be more, but they've dropped support for many of them because nobody uses it. So most of the stuff that you can possibly use is already here. So we've got S-Bus protocol, we've got Spectrum protocols, we've got F-Port, Crossfire, Jetty, stuff like that. So everything is actually there. You don't have to worry about it. For any hardware that you buy nowadays, you will find support for it. Now, modes are just like in Betaflight, the modes tab. So the only difference is that we have navigation modes, hence why it is called iNav. and the navigation modes that I have selected here. And I can post, if you're using the TX16S, I can post my model file online, so you don't have to worry about modes. You'll just have to load the model and load the diff from here, the modes only, and you can use everything already there. I've set up a few switches, so acro mode is enabled by default. Then we've got horizon mode and manual mode, just in case we need to take over in manual mode. I've got a course hold mode, which is paired together with a soaring mode. That allows the aircraft to dip the nose by 5 degrees and just kind of land itself in a straight line. So the 5 degrees pitch down ensures that it can kind of keep straight, keep an airspeed, and the course hold mode allows you to stay on a particular course. So once you have lined up with your runway, you can just land on it can land on its own. You have to time it a little bit, but it's possible. Then we've got cruise mode. Cruise mode is essentially you set up a throttle position, a throttle value for cruising, and it will maintain that throttle value depending on your airspeed. It might and whether you're losing or gaining altitude, it will adjust your throttle, and it will just cruise. So you give it a direction, put it into cruise mode, and it will just keep going straight. Loiter mode or circle mode, how it used to be called, is just you at that point when you flick the switch, it will go into circle mode, so it will circle above the point that you have designated. Return to home is essentially return to home, so it will come back to you and loiter around the takeoff location. Auto tune is something that you will definitely need to do on your first flight. And the interesting thing is, now that we get into this, is the nav launch mode. So this is auto launch, and essentially when this is enabled, there is a particular procedure. So the procedure is you enable launch mode, you arm, and then you push the throttle stick up to 50%. You do a bit of a fake chuck with the aircraft, the motor will spin up, and then you can just throw the plane and it will automatically launch in horizon mode. So it will keep level, it will go under a designated angle, it will go upwards, and it, once it reaches the end of the auto launch mode, it will go into a little transition mode where it will level off and hand over controls to you in acro mode. If for any reason you touch the sticks, it will exit. So the aileron, elevator, or rudder stick, it will just exit the launch procedure. We can switch OSDs as well, and I've got my OSD switch set up as well, so that's something that you can do. And at the beginning of the stream, I said that you can do pit tuning during flight. The way that I've set it up on my radio is I'm using the rudder and throttle trim switches in order to cycle through a couple of these and just increase or decrease their values. So we can adjust the roll pitch we can do like roll P adjustment, I, D, then we can do feed forward and the rates, and that basically happens for all of them. So you just cycle through, and I'll be doing a follow-up video with the DVR recording on how that's done. There is already a video, I think, on my YouTube channel, so you can have a look how it's done in flight. But essentially, you start off with lower values, you start increasing them, and if you start noticing strange behavior, you decrease the values to a stable. And of course, it's much more detailed than that, but this is just the boiled down version. Now, the GPS settings, you can select what GPS protocol you're using. It supports u-blocks, a newer version of u-blocks, NMEA, and MSP. So you can actually have a fake GPS, if that makes any sense. But yeah, that's not important. So most of you will be just using NMEA or u-blocks. If one of them doesn't work, try the other. It's as simple as that. We don't have a magnetometer, so we won't be looking at magnetometer, but here is where you can change the pitch of the magnetometer, you might need to adjust this, because otherwise the effect of not having your magnetometer aligned properly is toilet bowling for drones, so for quadcopters and so on and so forth. And for airplanes, it makes no difference. So, or it can make a bit of a difference, but actually the magnetometer is not used for any of the navigation modes. It's just using the GPS locations. You don't have to worry about magnetometer. It doesn't need the mag, unlike Betaflight. And, well, actually Betaflight doesn't need magnetometer, but if you use Inav on a quadcopter, you definitely need magnetometer. That's the way it works. We can also set up a flight plan. So if we have a look at a flying location, I don't know, let's just choose whatever here. We can set up a little flight plan, and you can change your defaults. So your default settings are in centimeters per second, and if you are loitering, then you have a radius. Here we currently have undefined, but let's say that we wanted an altitude above ground of 100 meters. So that will be, that'll be 100, that's 100 centimeters, 0, 0. Now we are at 100 meters. So that's our target altitude. And if we click on a point like that, we define a waypoint mission, and you can see that the waypoint should have done that. Well, anyway, that altitude needs to be, let's say, 100 meters. And you can see that it will show you a little conversion on the side. I guess you need to press save first, and then it will do it. So that's just waypoint missions. You can set up any waypoint mission however you like. There are user actions that you can do at those waypoint missions. So for example, you might want to set a heading at that position. You might want to repeat. You might want to jump. And you have P1 and P2 parameters. So for example, if you wanted to repeat this waypoint mission 10 times over, you would select 10 over here, I believe. No, it's parameter 2. There we go. So it will change here visually. You can see that we are repeating this 10 times over. And that's just how it works. So it will repeat this mission. This is interesting for if you're trying to do like an endurance flight or anything like that. The procedure to load the mission would be to, first of all, save the mission to the flight controller, and then also save it to the EEPROM. Now, once you unplug the power, obviously the EEPROM will lose power, and it will the flight controller will lose power, and it won't be loaded anymore, but it will be still saved to EEPROM. So what you need to do after that is to just load the mission from EEPROM, and there's a stick command in Inav in order to load that mission. Let's go to the next one, which is OSD. Pretty self-explanatory, but it does have a few more items than the standard OSD in Betaflight, such as glide slope and a glide calculation. So if you run out of juice, you can throttle down. You'll still have a little bit left. Your power consumption will drop, and you will have things like your glide estimation. And here they are: glide time, glide range. So you can, and a glide slope. So if we turn these on, you can have useful features like that. Let's see if that's gonna work. There we go. So we can, for example, put these over here like that, and that will give us our glide estimates. So after that, you press save. What's important is when you get your new flight controller, you do need to load the fonts. You just click on Font Manager, choose the font that you like, or a specific font file that you might want to use, and that's it. So that's pretty much it. The LED strip stuff is exactly the same as in Betaflight. So if you haven't used this before, just a quick explanation. You first go into wire ordering mode. So you select which is your LED 0, LED 1, LED 2, and so on and so forth. And after that, you exit the wire ordering mode. You then press the LED that you're interested in, and then you change the color. Now, for this particular build, something I can show you. If you want to have 2 different color LEDs underneath each of the servos, and let's see if my GoPro is actually going to turn on again, because I think it just overheated. Let's see if that's going to work. Nope. Okay. No, unfortunately, GoPro doesn't turn on. But in simple terms, if I choose paint like that, so you've got 1 LED on one side, 1 in the middle, and a second LED on the other wing. So the way that you would program this is because your LEDs have to be wired in parallel, so you have your 3 connections on your flight controller, 5 volts, ground, and the LED pad. You will wire 2 connections to 1 LED. Sorry, 3 connections to 1 LED, then 3 connections to this intermediate LED. These 2 are going to be both LED 0. And then the third LED is going to be wired in series, and that's going to be LED 1. And that's exactly what I've done here. So I've got 0 and 1. And so I do have an internal LED that lights up red. If you put some black shrink tube, you can essentially turn it off in a way. And then, of course, you have black box. So black box is just the standard black box that we're familiar with. You can record your black box information and then look at flight data afterwards. But now, let's have a look at how you go about installing Inav 6. So just go on Google, go on Inav releases. It will take you, the first link will be the release page for Inav. If you go down, you will have your information here. There are some default hex files that you can use for flight controllers. But actually, what many people do wrong is they go on Inav and just type it like this and don't realize that actually what they're looking for is the configurator. So actually, you need to go on Inav configurator, releases, and download the configurator, because that's how we will actually download the firmware. Now, one thing I didn't show you was how to take a dump of the file. Sorry, that sounded wrong. But how to do a dump and diff for your file, for your setup. And this is very useful because as new versions of Inav come out, you will be able to reuse some of those features, and we will definitely be reusing some of them in just a moment. So we can see here, we've got Inav Configurator 6. This is the latest release. If we download the Windows version, we've got the Windows 64 executable. So let's just download that. Inav used to be a lot bigger, so this is actually pretty good. 88 megabytes is pretty decent, but unfortunately my internet connection seems to be abysmal at the moment. I should have downloaded this previously. Anyway, we can have a look in the meantime. We can have a look at the AliExpress link. Actually, I ordered this and it arrived within 2 weeks, I think. It was really fast. Once it got to the UK, it was very fast. It literally gets delivered via a company called PX4, I think. And they're very, very quick when it comes to things like this. Now, some of the things that you'll need for the build is, again, this ESC, and I'll be posting a link somewhere. Post a link and you'll find it. These are potentially the right servos that you could use for this build. They're very small. The reason why I use them is because they fit in thickness within the thickness of the wing. So once you cut out that opening, they will fit nicely and flush. But otherwise, you could go for other servos. Okay, we can run that. That's fine. Install for all users. So there we go. And that will be our Inav 6 configurator. But just going back to this, I get most of my stuff from Hobby RC simply because they have really fast delivery in the UK. What you could get if you type in Emacs and you want to get your servos from somewhere else, you could go with you could go with, I think it is these servos. They are 6-gram servos. Not sure. I'll post a link. There we go. 4.1 gram servos. So this airplane is actually using these ones, the ES9051. I have purchased the 9251. So these are 2.5 gram servos, but actually the 4.1 gram servos also work fine. Dimensionally, these fit perfectly into the gap, but not in thickness. And if you're looking to do it like I did, which is to cut open the servo mount and have it flush with the wing, thereby increasing your efficiency, you can go with either one. I mean, both of them will work, and both of them are 5-volt servos, so you don't have to worry about the voltages. I'm using the Happy Model Open VTX transmitter. Unfortunately, this one is again out of stock because it's very popular. It's very cheap. It's, I think, the cheapest VTX that you can get at the moment for the power output. Of course, there's other ones, but if you have anything laying around that's tiny, you might want to use that. And something that you might want to get if you do get the BN220, and be careful with this one because there are also BE220s, which I think are fakes. But the BN220 is a very reliable GPS, always gets more than 10 satellites, so positional accuracy is fantastic. And this is a really nice, cheap GPS. It's like £10 per unit, so it's pretty good. But what you might want to get is, if you go with this one, it only comes with this PVC cable, and that's not very flexible, and also kind of melts when you try and solder it to the board. So what I got was this little JST SH4 pin connector, and this is a very nice and soft silicone wire, as you could see previously in the build video. So yeah, anyway, let's go to Inav and I'll show you the flashing procedure. Now, if you saw that daughter board earlier, there's a little button, just like on every other flight controller. You press the boot button, connect your flight controller, or you just connect your flight controller. Then it will show up here. That's fine. You have Inav running. And then something that we will do is we will use the Impulse RC driver fixer. So once that's on, it will get the board into boot mode automatically. So you don't actually have to press the boot button. Sometimes the boot button may not work on these daughter boards, and so this is a very easy way to get access to the DFU mode if you needed to. So if we go on Firmware Flasher, let's put these side by side with this window here, so we can see here what the name of the target is for Inav. This also supports ArduPilot. So some of you might be using ArduPilot. It's, also a very nice bit of firmware, but obviously since this is an Inav stream, what we're looking at is this name here, Maytag F405TE. If we go into the search box and we type in F405TE, it will show us the Maytag. There is 2 versions available. I guess this is you have to read the specifics of this release. The SD release, I guess, is using some pads for additional soft serial or what was it called? It was for additional UARTs, I think. I'm not sure. We'll have to check. Anyway, you always want to make sure that you have full chip arrays, and then we can choose Inav 6. This is the latest version, released just a few days ago. And of course, we have unstable releases as well, but we're not going to have a look at those because this one is good enough. We load the firmware online, just like with Betaflight. And let's get that into screen. And we can flash the firmware. This will just take a second. Now, something that I prepared earlier was the dump and diff file. And if we go into this folder here, by the way, this folder is on my Google Drive link. So anything that you want, you can take from here. It's got a bunch of information. It's got 3D printable models. It's got Lua scripts, software, firmware, custom firmware for your EdgeTX, OpenTX. All of this is available online. You can have a look if you need it. By the way, these were the stick commands that I was talking about. So these are Inav stick commands to do various things in the field if you needed to. So whilst your quad is your quad or your airplane is disarmed, you can use these stick commands to do various things. But anyway, not going into those at the moment because this is just a basic setup video. But in my Inav and here, we can see that we've got the LDARC 450X. That's the dump file. I'll just set that aside for just a moment. And I just want to show you what it looks like when you first connect to a just flashed board. So once you click connect, it will give you this default options menu, and you can choose what it is that you want. So we have airplane with a tail, airplane without a tail, rovers and boats, mini quads up to 7 inches, 5 inches, and 3 inches. Essentially, the PIDs, the default PIDs are different with those, and the rates, I think, as well. So the defaults will be loading that, but we'll be loading the airplane without a tail, or we can just choose keep current settings, which is not going to apply anything, but I'm going to go with this just to show you what it looks like. So airplane without a tail. So that's currently sending a bunch of CLI commands in the background, and at the end it will be followed by a save command. There we go. So it has just rebooted, and it will come back in just a moment. There we go. So airplane without a tail. Now, if we look into the calibrations tab, we can see that this is now not calibrated, right? So in the setup features, you can see here accelerometer calibrated. So the pre-arming checks show that it's not calibrated, and the runtime calibration has also not been done. So in order to get all of that done, we do need to calibrate. I'm not going to calibrate this now because essentially you want to calibrate it once while the flight controller is outside of the airplane and you don't have anything soldered to it. And I did this basically before starting the build. So you flash your firmware, then you start to actually build the plane around your settings that you have chosen. Now, of course, the mixer will be blank. But as I told you before, this is just the default, so you don't have to really worry about this. What we'll be doing now is just going into the CLI and using our diff file in order to just copy everything over. Well, you can use the diff file or you can use the dump file. The dump file is just more comprehensive and has everything that you have set up, whereas the diff file is only what is different from defaults. And sometimes that doesn't include all of your settings. So you might have changed something that you need to keep, so to say. So you really want to use the dump file. If there are any conflicts within the dump file that do not match the current version that you're flashing, those will be shown, and you can review them and change the parameters if you need to. Sometimes the names are known to change. So there was IMU and gyro being used previously. Now the terminology, they've changed to accelerometer and something else, whatever it was. So it is slightly different depending on the Inav version that you're using. But if you're setting this up from scratch, which I assume you are, then you don't really have to worry about this. So all I did was I copied all of the settings that I had previously, and I'm just going to paste them in here, and we'll see what happens. Maybe we'll see something that I'm not expecting. Maybe we'll see something that is different from the pre-release versions. And yeah, this might take a while. So let's see if I can fix the GoPro in the meantime. Because for some reason it doesn't want to turn on now. Yeah, that's very strange. Unfortunately, I think the GoPro is dead. But what I will do is I'll switch to another camera and I will continue to show you stuff. Unfortunately, the image quality of the other camera is not that great. But it will do the job. So let's see what I can figure out here. There we go. I guess that is working, but as you can see, the image quality is just garbage. But at least you can see something. So let's just let's just bring that over here like that. So you can still see a little bit of what's going on. There we go. Now we've just applied all the defaults. You see that there was nothing there. At the end, the last command is save. So after the information is saved, it just gets applied. Now something that we can do, and I'd like to show you what the final product of this is, because now everything is working. Let's have a look at my model here. There we go. So as you can see, that is the default model that I have. You can change the picture if you want. You can change the name of the model that you want. But if you wanted to use it straight out of the box, so to say, you can just copy this Inav model. This is kind of like a default model for both flying wings, fixed wings, and stuff like that. That's got some interesting additional features, like being able to turn on and off a recording camera. So if you have something like a run cam, for example, you might want to have the option to turn that on and off. And the button or the switch that's assigned to this is just this momentary switch, as well as the arm disarm. So something that will happen if you arm, it will go on and it will say on. And if I press this, it will say off. I don't know if you can hear that, but let's try. I don't know if you can hear that very well, but essentially what's happening is we can turn on and off a recording that is a run cam device or similar. So if you are using a run cam on any of your builds, then you can turn it on and off using this, and you can turn on and off the recording basically. Anyway, so I'm going to put the transmitter aside and just plug in the battery, because now we don't need the USB connection anymore. Or actually, we can just keep it in there. and just monitor the outputs. By the way, these are the kinds of batteries that I'm using. This is a 300 milliamp hour high voltage battery. It is also from Emax. I found these online for really cheap ones and just found some good use for them now, I guess. So there we go. You can see a solid green light. That basically indicates that our connection is established. And if we have a look at this, you can see that the servos are moving. There we go. So we do get movement. If I arm, the motor will also come on. There we go. So that's all working. And if we plug this in now, we can have a quick look at the BL Heli S stuff that I was mentioning before. So in that folder, the remote control folder, if you go into firmware, I think it is. Nope, sorry, software. And then we have BL Heli Suit 32 and then BL Heli Suit without the 32. We can just, so that is on UART3. No, we're not downloading the latest firmware. We don't need it at the moment. And we can connect and read the setup. So as you can see, it has found that one BL Heli S firmware ESC has been found, which is exactly what we want. And the only thing that you might want to change on these is basically the ppm min throttle and the ppm max throttle, because those are the default are different. So you can see that the default is 1148 and the max throttle is 1832. I've changed these to 1000 and 2000, and that is simply because in Inav, that is the output that we have, right? So if we open up Inav, I'm guessing, yep, that's the wrong version of Inav. So let's have a look at Inav Configurator 6.0. There we go. So if we look at this and go into our receiver tab, we can see that my throttle channel, yeah, it's moving between 1000 and 2000. And that's essentially how we want things to be. Aileron channel works, elevator works. Now, one thing that I'd like to mention, and I'll make the video a bit bigger just so you can see the movement. One of the issues that some people have is they can't figure out which servo needs to be reversed and how. But the easiest way to figure it out is to go into the Outputs tab, which is where we can reverse our servos. And let's say it was like this, okay? So we save it, and we can see it's going to take a second. The settings are going to be applied. It's going to do the beep beep again. And you can see, as I am pulling on the elevator stick, so I'm just basically pulling up like that, we can see that the outputs, and we can see the Outputs tab just here underneath, both are moving in the same direction, right? But we can also see that one of them is moving incorrectly, right? So this one is going up. Let's have a look. So basically, on the screen, that one is going up, which is good, but the other one is not. And depending on how you have wired your servos, you might want to reverse one of those. So the first step is to reverse the correct one. You can just reverse either of them and see which one is the correct one. Don't have to do anything to the mixes. You don't change the mixes at all. You just leave them as they are. And as we can see now, they work fine. But the check that we really need to do is we need to go into horizon mode. So just to show you that we are in horizon mode, I'm just going to move this aside a little bit. There we go. And I will go into the modes tab. So again, modes tab. Now we are in horizon mode. You can see that the mode is active. It shows you that the mode is active. And when we are in horizon mode, we want to make sure that our servos are turning the correct direction. So obviously I've turned it now opposite to me. I've turned it clockwise, and we can see that this servo is going up and the other one is going down. If I turn it the other way, you can see that this one has gone now up and the other one has gone down. If I go down, then both of them go up. If I go up, then both of them have gone down. Now, something that you might want to tune in flight is the level mode adjustment. And essentially, if your flight controller is just slightly pointed down or slightly pointed up, or your airplane wants to fly with a little bit of nose up attitude, which is sometimes the case with flying wings, then the one thing that you'll need to change, and it's currently no longer a variable that you can set up easily, but you can do it via the OSD as well as via CLI commands. And I'll show you this in just a moment. So once our OSD loads, I can show you how that works. So if we go into the OSD layout 2, in this case we've got OSD layout 2 as the one where we do our PID tuning, and there are these two parameters here. If you hover over the parameters, they actually highlight. So if we scroll down and we hold that over there, you can see that those will highlight. And there is the board alignment roll and board alignment pitch. And essentially what you can do is you can fly in the throttle value that you're cruising at, and then slowly bring up the pitch value or bring down the pitch value depending on your orientation and so on and so forth. So we can have the pitch value go up or down depending on what it is that we want to achieve in terms of our flight. So if we want a level flight where we don't have any altitude change, we might want to adjust that value so that our plane flies level at the cruising throttle. And once it does that, so it's not losing altitude, it's not gaining altitude, it's just flying level, at that point, you know that you have adjusted your board alignment pitch. The other thing that you can do, which is very similar to this, but has a slightly different effect, is you can go into your modes tab, and right underneath auto tune, you have servo auto trim. Now, you can auto trim the servos and leave the board in its initial state. So that's going to work. Or you can adjust the board alignment. I prefer to do the board alignment. That is the old method of doing it. Some people prefer to do the auto trim method, and others go into advanced tuning. I think it was advanced tuning. And they change parameters within that. So I'm just going to unplug the battery so it stops beeping on me. So there are some people who want to change so this is the cruising throttle value. So 1,400 or 40%, that's my cruising throttle, which will be used in all navigation modes when the aircraft is cruising. And then we can go into, I think it was PID tuning and then mechanics. So if you go on PID tuning and mechanics, we have fixed wing level trim. And this is the third option that we can use in order to designate what is level and what is not level. The good thing about this is that you do have a help menu. So if you click on the little question mark, it will show you what values you can use. So plus or minus 10 degrees, in degrees, 5. So it says very nicely explained. The documentation on Inav is great. In degrees, plus 5 means that the airplane nose should be raised 5 degrees from level. So if we put in plus 5, and this is accurate to 0.1 of a degree, so you can have something like 1.2 degrees, then it will essentially go up 1.2 degrees, and that will be recognized as level flight. Most of you, if you're using a build like this, you can mount the flight controller level, make sure that it's on or near your CG, which is around here for me. And once you have it mounted there, you don't really have to worry about this. Just make sure that it's level, and that's it. So now, questions time. Has anyone got any questions on this? Faris? You are muted in Discord. Don't be shy. All right. Well, I guess no questions. So if anyone does have any questions, just put them in the comments below. I will have a look at the live stream at some point. And if you do have any questions, I will make sure to answer them. So yeah, other than that, thanks for watching. Thanks for joining, and see you soon.